Good afternoon, everyone. Today we're going to discuss a very important topic on machine learning, on machine learning. And last time we did KNN, K-nearest neighbor. We haven't finished that, but let me just regress from that. I'll just record the continuation of that kasi ito yung mas mga importanteng topic, so I decided to because of in the interest of time and limited na yung mga sessions natin, simulan na muna natin dito sa mas nagagamit na model, which is decision trees. No? So today we're going to do a decision tree model. This is still part of machine learning. And the package that we're going to use is the party package. So kindly load that, install that packages. You know what to do, class. So install nyo muna, tapos i-load natin. Okay, and then make sure to, you know what to do, class, to load the data set, yung cardio. Okay, you can, if it's loaded in your project, you can use the read_CSV. It's up to you, class, on how to load it. I'll just okay, hindi nyo makita. So anyway, dito na lang. Import dataset ko na lang. CSV from base. Okay, so I place it here. Desktop. Nasa hindi ko makita yung project ko. And I don't want to create anymore. I'll just make use of this one. Where's the FINLYTS? Cardio. Okay, name cardio. My heading, yes. Okay. All right, import. Okay, and kindly chat, please, if you're done with it. If you were able to access the data. I'll just replace this. Okay, good. So let's wait for the others to load their data. Okay. So I think everybody's who hasn't loaded the data. Kindly chat, please, para alam ko, para we can give you a bit more time. Okay na? Okay, good. So I think everybody has loaded the data. Let's take a look at the data first. Okay, tingnan lang muna natin dito. I-view natin. So ang dami niya, no? You have here 27 wait, ilang variables to? 1 to 27 of 2000. 22 columns, which means there are 22 variables. Okay, 22 yung variables dito. So these are medical data to, no? May pounds, may AC. This is something to do with the body measurements, no? ng individuals. There are 2,126 respondents. So mga patients to, tinignan nila yung minessure yung mga metrics na to. We will not go into the details kasi hindi naman tayo medical students, no? But the objective here is to try to predict this. My NSP to, no? I'll explain what NSP is all about. Okay. So let's go back and describe natin yung data. So ito yung mga to class. I will not give this to you, no? Kayo na bahala magsulat niyan. Just tell me to pause if I'm going too fast. No? So describe natin yung data. Let's review na natin. Tingnan natin yung structure niya at saka yung summary, structure ng data. So this is a data frame with 2,126 observations, 22 variables. So ito yung mga variables niya. Meron tayong integer, meron numerical. Okay, integer. And then sa ilalim, merong NSP is integer, 2113. That's very important because we need to modify that. Kasi NSP is a classification. So dapat factor siya. No? Okay. So, aside from that, pwede natin i-summarize to. You can see here the 6 number summaries for most of the variables that are numeric. And even the NSP, nag-number summary din siya, which doesn't mean anything kasi hindi naman talaga siya numeric variable. Okay, clear so far, class? Yung una natin. Pakichat naman, please.
Yes, sir.
Okay, thank you. All right. Now, as I said, si NSP, hindi ano yan, hindi siya numerical variable. It's actually a categorical variable that classify the patient into normal yung condition niya or suspect siya or pathologic. Ibig sabihin yung may sa heart, no? May condition sa heart. So itong respondent number 1, if you take a look at our data, si cardio. So respondent number 1, ito yung mga conditions niya. And yung heart condition niya, 2. So that means suspect siya. Suspect siya for heart ailment. Si number 1, ito, ang finding sa kanya normal siya. Okay? So these are actual data. No? So ito yung mga diagnosis ng doktor. No? Number 3 is pathologic. So actual data to class, no? So given this data, we would like to create a model so that given certain parameters, maybe not all, but certain parameters, pwede natin ma-predict kung yung taong yon ay 2 or 1 or 3. No? 1 is normal, 2 is suspect, and 3 is pathologic. Okay, so parang ano siya, no? Parang logistic regression, pero ang logistic regression kasi dalawa lang, binary lang yun. No? Dalawa lang, yes or no, true or false. Kapag more than 2, multinomial regression na yun. But in this case, we're not going to use multinomial regression. We're going to use what we call a tool in machine learning called decision trees. No? So decision tree ang gagawin natin dito. And we will look at that in a while. All right. So our variable of interest is NSP. Sabi natin categorical siya. So dapat natin class i-convert. Okay, so you know, we have done this in the past. Convert natin yung NSP na variable natin. So we'll create a variable dun sa cardio data natin, $NSPF, no? NSP factor. Okay? So this will create now a new variable sa cardio data natin. Take a look at this. Diba? Pag dollar, ibig sabihin yan, from the cardio data, mag-i-introduce ng panibagong variable. And then, this is as that factor, cardio NSP. So what is this doing? It will create a new variable, NSPF, and then it will convert your NSP into a factor. Okay, so I'll give you time to write that, and when you're done, kindly run it, and then tell me, class, what you see in your cardio. Tingnan natin kung ano nangyari sa cardio data niyo. Pakichat kung ano nangyari. I expect 8 responses class. I expect everybody to respond. Maliit lang kayo, so alam ko, konti lang tayo, so alam ko kung sino yung ano. I hope everybody responds class. I want to make sure that everybody is able to follow along. Okay, I'll wait for the others to respond before I look at your answers. I look at your responses. 4 pa lang. So, target natin is 8 responses. Let's give your classmates a few more seconds to run the code. And my question was, what happened to your cardio data? If you view your cardio data or you click that dun sa tab na may cardio, ano na-notice niyo? Okay, how about the others? May 5 pang kulang na hindi pa nagre-respond. Okay. 3 pa. Okay. So 2 more. I hope you're not pressured and just copied the response and then dapat sana ginawa niyo sana. Sige, who's not yet done? We'll give you extra time. Kasi kailangan natin yung class, yung NSPF na yan. Yeah. Okay. So let me see your answers. New column. Okay. New column. New column. New column. Okay. Yeah. NSPF. Yeah. You're correct. Yeah. Good. Good. I'm happy that everybody got this. If I run this, let me run this myself. Okay. And then if I check my NSP, my cardio data. Okay. Meron ng NSPF dito. No? And take note. Okay. Yung mga values niya, ganun din, 2, 1, 1. However, if we check the structure or the class, tingnan natin, no? Class ni cardio dollar and SPF. Yan. Tingnan natin yung class niya. Ano ba yung class niya? Okay, factor, no? So tama tayo, factor na siya. If you compare that with yung class ni NSP, okay, just for purposes of discussion, Control C, Control V yung class ni NSP. Okay, integer si NSPF factor. All right. Okay. Clear so far, class? Okay, chat nga please kung nakakasunod tayo so far.
Sir, for me
Yes.
po, instead of integer, it's numeric for me.
Okay lang. Oh, okay lang.
Okay, sir.
Sige, thank you. That's okay lang, whether it's integer or numeric. Okay, so as long as yung NSPF dapat factor. Okay, now what do we do now? Sabi natin, gagamit tayo ng modeling called machine learning para makapag-develop tayo ng model para ma-predict natin kung yung isang tao, new data, kunyari, may isang bagong patient, papasok doon. The hospital can make use of the model in order to come up with a prediction kung ano ba to, normal state ba to o suspect ba siya for heart attack, for heart disease, heart ailment, or pathologic ba tong taong to. Yun ang ginagawa nitong model nito. And take note, ang dami mga variables, no? So we can make use of that. Yung decision tree, kaya niyang kahit ilang variables yan. Sa dami-dami ng mga variables. But we're going to limit ourselves, no? Ililimit lang muna natin. Basta gusto natin makuha yung taste ng ng machine learning, ng decision tree. No? Okay, so what do we do with this? Sa machine learning concept class, we don't use everything sa data. Di ba meron tayong 2,200, 2,000, 2,126 observations. Okay? If we're going to use all of this, we will fall into a trap called overfitting. Ano yung overfitting? Overfitting is when you create a model from all your data. So ang mangyayari niyan, parang napaka-specific ng model natin for that data. So what's done is usually to partition your data, split your data. Okay, ang gagawin natin, split natin yung data natin into a training data and into a testing data. Sulat ko yun. So what do we do? Clarify ko lang class, hindi natin ginawa sa ano to, no? Sa Arima, hindi tayo nag-partition ng data. Right? Am I right, class?
Yes, sir.
Okay, sige, good. Sometimes kasi sa regression ginagawa din yan, especially kung malaki yung data, no? That's a good practice. Pero sa machine learning, talagang pinapartition yung data. And there are different ways to do this. This is just one example. There are other ways. Yung MLR na ginamit natin na package yung last time in-introduce ko sa inyo that nung Tuesday, that has some very good partition capabilities. Sa atin, ang gagamitin lang natin, napakasimple lang, no? Yung sample function lang. So what happens now is that you have 2,126 observations. What we're going to do is to split this into a training data set and a testing data set. So what are we going to do? We're going to use the training data set to create a model. And then pag nagka-model na tayo, gagamitin natin siya sa data na hindi pa nakikita ng model natin, which is the testing data set. And try to see if yung model natin will run well even with the testing data. Okay? Paki-ano nga class, paki-chat nga kung clear yung concept. Conceptually, madali lang naman, di ba? Again, ang gagawin natin, split natin yung data natin. We have 2,126 observations. We're not going to use everything for our model kasi sabi natin overfitting yun. Okay, so we're going to split randomly our data into training. Anong gagawin natin sa training? Yun na ang imo-model natin. Tapos, pag natapos na natin model natin, gamitin natin yung testing data natin para malaman natin, ma-check natin kung okay pa rin ba yung model na generate natin sa training data. Okay? So that's what's happening here. Okay? So let me clear now the drawings. Okay. So let's take a look at this. The first one here is set.seed. Check ba? Check. Okay. Set.seed class. Saan ginagamit to? I think we discussed this before, di ba? Pag nag-random tayo, nag-random number generation tayo, when we use set.seed, we will be able to generate the same random numbers. So, importante sa atin to, set.seed, gawin nila natin 1, 2, 3, 4. And then, what do you see here? Okay, PD. We're creating this, partition data, and then, sample. So, tingnan natin kung ano ba yung sample. Sa help na lang, dito. Type natin sa help. O kaya, dito na, diretso na. Help sample. I think we used this before. So let's just okay. Time date, time series, ito sa base, no? Dito sa base galing package base. And then, dapat sinulat ko yung dapat dito, para mas mabilis. Help. Anyway, ito na. Click ko na dito yung sample. Okay, and let's see what this does in sample quick review lang to class ha, kasi na ano na natin yung sample dati. No? So, para alam lang natin ito. Sample. Random samples and permutations. Let's click this. Okay, so sabi dito class, this is from the base package. Okay, sample takes a sample of the specified size from the elements of X using either with or without replacement. Okay, so this is the syntax. Sample ng X. Tapos i-identify natin yung size. Tapos kung replace ba is equal to true or false. And then kung may probabilities. Okay. So that's the, ang gagawin nito class. Okay. It will partition our data. So here, sample 2. Ibig sabihin, dalawang samples tayo, dalawang sample size. The data will be partitioned into 2. So pwedeng 3, pwedeng 4. Okay, tapos ano yung size natin? Yung size is 2126. And then I will just use n row ng cardio. So mas maganda to kaysa yung 2126 ilalagay natin. Okay, so that pag nagbago kunyari yung cardio natin, nagbago yung size niya, at least generic tong function na to, no? N row ng cardio, and then replace is equal to true. So what's replace is equal to true? Ano ba ibig sabihin ng may replacement? If you recall dati class, so parang ano yan, parang meron tayong let's say urn or container. Okay, so we have here 2,126 balls, no? O ping pong balls. Tapos we draw out one, okay? And then we specify the number, kunyari number 180, okay? And then, pag replace is equal to true, ibig sabihin ng class, pwedeng ibalik siya dito. So, ibig sabihin na maintain pa rin natin yung 2,126 na observations. Right? So, is it okay for the that particular sample to be chosen again randomly? Yes. Okay lang yun, no? So, replace is equal to true. Otherwise, class, pag replace is equal to false, pag na-draw out na yung sample na yun, set aside na yun. Hindi na siya pwedeng maulit. No? And then yung probability, anong probability? This will now split our data. 80% sa training natin and 20% sa testing. Okay? So usually ang range nito, proportion to 70-30, mga ganun. Okay? If kung masyadong malaki naman yung data set, okay lang naman na mag 70-30. Okay? Pag medyo relatively mas mababa, then mas mataas yung sa yung training ng ratio 85-20, 85-15, 80-20, etc. Wala namang hard and fast rule. But we have here 2,126 observations. Ang 80% na mga 1,600 plus, di ba? Okay, and 20% yan is around 400 plus. So for a testing data set yung 400 plus na observations, okay na yun. Okay, so let me clear the drawings. Okay. All right. So, i-run muna natin to class, no? Run natin control, enter. Okay. And then, you have here PD. No? PD. Yung partition data natin. I-vector siya, no? So, kunin lang natin yung head ni PD kahit na first 50. Okay, I'm printing now si PD. Okay, in first 50 observations, I run that. Okay, so take a look at this. So what's happening here? So anong nangyayari dito, class? Yung bawat observation natin, ba? Yung first observation natin, it will go to group 1. Kasi 80% si group 1, di ba yung training natin? So talagang mas marami yung mas marami magiging group 1 natin yung training. And take a look, 1, 1, 1, 1. And then this is 2, which means this will go to the testing data. So you notice, mas marami yung mas marami yung mga training. Natural kasi 80% siya, di ba? Okay? So anong nangyari, class, yung natin, yung cardio natin, yung mga observations siya, may mga particular na numbers na yan. Parang na-classify na siya. Yung first observation, group 1 yan. Second observation, 1. Third observation, 1. Fourth observation, 1. Fifth observation, 2. Okay? Na-randomize na yan. And question, did we get the same values, class, ng PD? Paki-chat nga, please. Did we get the same values in PD? Everybody, please, paki-chat. We're waiting for the others. Good. Sige, tatlo pa. Dalawa pa. So for one more. Sino pa hindi nakapag Yes. 8 na lang. Nawala na siya. Bakit nawala na siya? Okay, yes. Okay, good. So everybody, ba't nawala na siya? 8 na lang tayo. Kanina 9 tayo. Okay, we should get the same class kasi itong set that seed natin, di ba? Kung wala to, then magiging iba yung sample natin. Alright, then this one, okay, we're creating this object, train. Okay, train natin is yung cardio na subset natin where your PD is equal to 1. Okay, di ba yung PD natin 1 or 2 yan? Okay, take note of how it's run. Cardio, brackets, bracket, and then PD is equal to 1, yung sa row. And then sa column, walang laman to. Okay, anong ibibigay nito, class? What will this give us? Can somebody explain, please? What will happen to this code? Okay, can somebody explain? Ano mangyayari sa code na yan? Tatawag ako. Okay, Fuji, what will happen to this code? Okay, Fuji, pwedeng i-unmute mo sa iyo. Fuji, could you unmute yourself? Paki-explain mo yung sinat mo. Wala ka bang Mike? Okay. Alright. So,
Hello, sir.
Yes,
Am I
yes.
audible po ba?
Okay, sige. Okay, Fuji, please,
Wait lang,
paki-explain.
sir.
Sige, may mic.
Um,
Rinig na.
Sir, sorry, hindi ko po kayo marinig. Wait lang. Hello, yun po, di ba, sir, kasi may siya, yung parang ginawa natin po yung PD. And then parang nag-sample po tayo, di ba?
Yeah. Create natin si PD na dalawang sample yan, di ba?
Yes
Actually,
po.
yung data natin na cardio, parang in-split natin into 2 samples, 1 at saka 2. Okay, so yung train natin, anong ginagawa natin dyan? We're creating an object called train. Tapos, ano ibig sabihin, class, ng cardio and then brackets? What's the meaning of brackets, class? There?
Ayun po yung number of Ay, yung sa rows po ba, sir?
Subset yan, di ba?
Subset of rows.
Sinasubset natin yan. Take note, di ba? Kasi si cardio, may row and column siya, di ba? Ano yan data frame yan. So, identify natin ano yung isa-subset natin. Yung first part dyan, yung row, comma, column. Take note, ang sabi niya, yung row, which be, dapat yung row na PD is equal to 1. Diba? So, lahat ng 1 dun sa PD, yun ang ipapasok natin dun sa row ni cardio and fourth train. Tapos, yung column, yung after row, comma, di ba? Column is wala nakalagay. So, ibig sabihin, lahat ng column isasama. Okay? Alright, so if we run this train data, control enter. Okay. So, review ko na lang. Review ko si train. Okay. How many observations do we have now for the train data set? 1718, no? Diba? Nabawasan na siya 1718. That's kasi 2126 times 0.8, 80%. So 17 so approximate, no? 1716. Hindi niya binigay yung ano kasi randomly generated siya. But there's a way, if you really want to be strict with 1716, pwede rin gawin yun. Ito kasi randomly generated, so hindi tayo magiging exact yung ano, no? Yung 80% ng 2126. Okay? So, ito na yung ano natin, yung train natin. If you check class, ito, 1, 2, 3, 4, take note of this. Ano yung susunod dito? Yung sa index. 1, 2, 3, 4. Tapos, ano susunod? Class.
2.
Hindi. 1, 2, 3, 4. Tapos ano? Tingnan yung index natin, no? 1, 2, 3, 4. Tapos?
6.
6. Bakit 6?
Kasi 2 yung panglima, sir.
Ha?
Ay,
Ano?
2 po yung panlima. Yung panlima.
Yung number 5, dun yung pupunta sa isang data set, di ba?
Yes.
Right? Kasi i-run ko yun na, hindi ko pa nara-run ko yun. Sana siya. Hindi ko makita. Ito. Okay, so let me run this. Itong validate, or you can call it test, depends on you. And then, i-review ko na lang din. View, validate. Para isang run na lang. Take note, ito, cardio din, pero PD is equal to 2, no? Okay. Run natin. So this is now our validate data set, no? Ito. Lahat ng columns present, andun din yung NSPF. Right? Andyan din siya. Pero, take a look at the index. Number 5, number 14, number 16. Ito na yung mga PD is equal to 2. And there are 408 observations. So ito yung 20% ng 2126 natin. Okay? Okay, pakichat please kung clear tayo so far. Clear tayo dun sa pag-partition ng data. No? Okay, good. Alright. So, na-partition na natin data natin. Anong gagawin natin dyan? Magmo-model na tayo. I-model natin i-model natin si train data set natin. We would like to create a model so that it can predict yung NSPF kung 1 or 2 or 3. Okay? But before we do that, tingnan muna natin yung dito hindi pa natin dito. Bago tayo mag-partition, tingnan muna natin yung ito outline. Table natin. Table yung cardio, dollar, NSPF. Okay. So we can see here, class, that dun sa natin, sa original data natin, marami yung ano, mas marami yung 1655 yung mga normal, no? And then dalawa yung 295 yung suspect, and yung pathologic mas konti. Tingnan natin class kung kung let's see kung ano nangyari dun sa Control Alt I. Let's see table. This time ang tingnan natin yung yung table. Tingnan natin yung yung sa train data set, no? Train, then dollar, and NSPF. Okay, 1348226.144. Okay. Ano nga natin? Tingnan ko lang yung check lang natin class kung medyo na-preserve din yung yung proportion. 16555 divided by 2126, di ba? Yung proportion class ng ng normal sa cardio. Are you following class? 1655 out of 2126 yung normal doon. No? Okay? So that's around 77%. Check lang natin kung yung pag-partition ba medyo na-maintain pa rin yung yung 1348, okay, divided by n row ni train. Okay, number of rows ni train kung ilan siya, di ba? 1348 yung normal kay train. Ang proportion niya, medyo ano pa naman, no? May konting difference pero andun pa rin yung basically andun pa rin yung proportion ng ng normal, no? Kasi importante na na-maintain yan. Otherwise, kasi what if yung pag-split niya, lahat ng normal halos napunta lahat dun sa sa train. Pwede 'yun, di ba? Pwede 'yun kasi dun sa cardio class, I hope you're getting what I'm saying. Sa cardio sa original data set, meron tayong 1655 na 1655 na observations. Okay, dun sa pag-split natin kay train, ilan na yung natin kay train? 1718. So, kung tutuusin class, okay, strictly speaking, pwedeng yung yung lahat ng normal, okay, pwedeng lahat ng normal napunta kay train. Diba? Kasi yung kay train, 1718 eh. So pag ganun class, magkaka-problem tayo. Diba? Kaya partitioning is very, very important. Kaya there are ways to ensure that yung kunyari, yung variable of interest natin, yung NSPF, may proportion siya. There are ways in order to make sure that yung proportion niya na-maintain pa rin. O tingnan natin yung isa, no? 295 divided by, gawin ko na lang n row ng cardio. Okay. Ilan yung proportion ni nung suspect? So 13.8. Okay, pero dito kay kay train 126 divided by n row ni train. Okay, 73 wait, bali. 126 ba? Ay, sorry, 226 pala. Sorry. My mistake. 226. 226, no? Divided by yung total number of observations in train. 13%, 13. Okay, so more or less class naman, na-maintain. Okay, are you getting me, class? Clear?
Yes, sir.
Hello? Okay. So you realize the importance ng ng pag-partition kasi sabi natin pag na-partition to na na masuskew yung yung proportion. Imagine kunyari lahat ng normal napunta kay train. Eh di ba halos lahat ng yun. Pag if i-model natin si train, then halos lahat yan normal. So malamang yan, may skew yung data natin, ma-skew yung result. Kung i-model, itetest na natin si validate data set. Okay?
Manually po lagi yung pag-check ng ganyan.
Ito malaki nandito.
May code din, no? May code din para gawin yun. Ito, pinakita ko
Bakit
lang.
di ako bumili ng beach, Bobby?
Merong ano.
Huwag mo na paalala.
Frances,
Sayang.
paki-mute, ha?
Ano ba?
Frances, ano ka? Hindi ka naka-mute. Okay. Alright, so I also wanted to show you yung paggamit ng cross tabs at saka ng ano. Pag dalawang variables yung tinitingnan natin, pwede yung gamitin yung cross tabs. Pag factors. Alright, so let's now move on. Okay. So, punta na tayo dito, class, no? So we're going to make use of this function C3. Okay. From the party package, tingnan mo natin, class, kung ano yung ginagawa ni party package. So I'll go here to packages. And then let's type here. Okay, asan yung salamin ko? So packages, I'm going to type party. So that we'll see din kung ano yung laman ng party package na yun. Party, okay, here. I'll click this. Hindi ko pa pala library, kaya hindi siya. Okay, let me run the library. Kaya hindi pa siya naka-click kanina. Alright, so, tingnan mo natin description here. Ano ba yung description na to? Okay. Balik ako dito sa documentation. Denied. Okay. Balik ako dito sa R. Ito, PDF. Access naman. Okay. Anyway, were you able to, class? To access it? Na-access nyo ba yung information, information about party package? Kindly chat please, kung nakuha nyo. Sa documentation kasi dito. Okay, so it's a laboratory for recursive partitioning. Okay, party is partition. And then, ano yung mga gamit niya? Okay, a computational toolbox for recursive partitioning. The core of the package is C3, an implementation of the conditional inference trees. So C3 stands for conditional inference trees, which embed three structured regression models into a well-defined theory of conditional inference procedures. Okay, so regression to, no? So we're actually classifying our data into tatlo yung natin, NSP, or factors 1, 2, 3, 4. So conditional inference tree modeling to. Conditional inference trees. All right. Okay, so let me go back here. Ang unang titingnan natin dito, class, is tingnan natin yung our first function that we're going to use is this one. C3, ito, no? From the party package. So this is C3, tingnan natin syntax. Conditional inference trees. This one. Okay, recursive partitioning for continuous, censored, ordered, nominal, and multivariate response variables. So this one will work kahit continuous siya. Okay? Kahit na nominal siya. Katulad ng natin ngayon, nominal, no? Multivariate response variables. Okay, so this is quite powerful. This is quite flexible kasi kaya niyang mag-split ng data. Okay, mag-inference, gumawa ng decision trees, kahit na continuous, kahit na censored, kahit na ordered, nominal, etc. Alright, and this is the syntax, yung mga pwedeng gawin. And then sa ilalim may example siya. Okay? I'll leave you guys to try to look at the example also. So here, class, ang gagawin natin dito, C3, and then regression natin, and SPF regress on. For our purposes, we'll just use the first three variables, no, to predict NSPF. Kasi ito yung cardio natin, maraming variables to, di ba? 23 variables. So we're just going to use for purposes of simplifying this and for purposes of example, gagamitin din natin si pounds, AC, and FM. Okay? Yung tatlong unang variables natin. That's why our function looks like this. So let's create an object called 3.1. Okay, from the party package, we use the C3, and then we're regressing NSPF on LB, AC, and FM. These are the first three. Observe the first three variables. Data, take note, class, data is equal to train. Okay, this is very important. Do not use the cardio data, but rather the train data. Okay, so let's first run this. Control Enter. Run natin ng isa-isa. So, tingnan natin si 3.1. Okay, it's a binary tree. Malaki, 1.3 megabytes. Yung laman niya, if I click this, you can see here, list kasi siya. So, ibang laman, no? Andiyan yung predict niya. Okay, andito yung data. Andito yung tree mismo. Okay, so let's continue. Ipa-print natin class si 3.1. Print 3.1. Okay, and what do you get? You get here the plot of the decision tree. Okay, so medyo nakaka-confuse siya, no? Maraming mga subsets dito, no? But this is just a conditional inference with 10 terminal nodes. Okay? Ano ibig sabihin ng terminal nodes? Gagawa siya ng tree, tapos 10 yung nodes niya. 10 yung final decisions. Asan yung mga nodes na yun? Yung may mga asterisk, the ones with asterisk. Okay? So C4, C5, C6, C10, C11, C12, 14, and 18, 17, 18, 19, 14, 17, 18, 19. If you count them, there are 10 terminal nodes. Okay. Feedback, please, if you got the same answer so far. Okay, thank you. Alright. So ito class, madali lang basahin to, no? Kaso nga lang, hindi siya magandang format. There's a better way to look at that later. Titignan natin. Okay, thank you. Okay, good. But it simply means this one class. Madali maintindihan lang ng decision tree. Sabi dito, di ba tatlong variables natin yung ginagamit natin, di ba? Si LB, ACS, at saka si FM. Therefore, itong tatlong variables na ito ang magiging basis ng ng regression, ng partitioning, no? Ng pag-decide kung NSP yan. Okay, first, ang sabi niya, if AC is less than this value, okay, yun ang criteria 1 natin, ang gagawin ngayon, pupunta kay LB. And then if LB is less than 136, ang gagawin, pupunta kay FM. Okay? And then if FM is less than or equal to 0.1198, then conclusion, okay, weights is equal to 405. Okay, so tingnan nyo dito, may mga weights dito. So medyo mahirap maintindihan, mahirap ma-appreciate to kasi this is not expressed in terms of kung NSPF, no? But rather in terms of weights. Okay? So we will go back to this later. Okay? Express muna natin itong 3.1 natin into a Ito yung print type. Tingnan natin yung plot type. No? So let's run this. Okay. Ito na class yung conversion yan in terms of a decision tree. Okay. Right. So take a look at this. If AC, di ba ito yung una, yung kanina? Di ba? If AC is less than a particular, naka-ano lang to, naka-truncate lang. Kaya hindi natin talaga makita exact na number. If AC is less than this amount, okay, then less than 0.001, then punta tayo kay LB. Di ba yung sinabi natin kanina, di ba? And then if LB is less than 0.001, okay, sorry, if LB is less than 136, ito, no? Then go to FM. Then if FM is less than 0.112, then ang answer niyan, node 4. Okay, so yung kanina class, yung sa, dun sa tinignan natin, nakalagay, di ba, 4 and then asterisk. Ito yung mga terminal nodes. Node 4, node 5, node 6, node 10, 11. Ito yung mga 10 nodes class. 10 nodes. And then, it tells us kung ano yung decision rule. So it tells us probabilities. No? Ang probability na 1 siya is this amount, around 0.7 something. Ang probability na 2 siya, which is suspect, is less than 0.2. Ang probability na pathologic is less than around 0.2. So dito masasabi natin na if it falls under this one, then ang answer niyan, normal yan. Diba? Ito yung normal class yung 1, di ba? 1, 2, 3. Right? Okay, pause muna ako class, nakuha ba? Gets class yung yung how we were analyzing the path. Chat naman please kung naintindihan. Okay. Alright, good. Sana naintindihan na. Okay. So, ganoon din itong kabila class. No? So, ito mga terminal nodes na to, it tells us kung ano yung result, kung how it was, kung ano yung prediction niya. Dito, sa node 6, node 5, ang prediction niya, pathologic. Diba? Ito, number 3. Dito naman, sa node 6, ang prediction niya is suspect. Sa node 10, normal, 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 normal. So mas maraming normal kasi mas malaki yung population nila, di ba? So dito ang node 5, doon lang yung prediction niya na pathologic, no? Tapos node 6, diyan lang yung prediction na papasok siya under suspect. The rest are normal. Okay. So tuloy na ako dito. Na-plot na natin, di ba? Ano ba yun? Na-plot natin. And then, pwede natin plot is equal to simple. Let's see what happens here. Alright. So, mas maganda tong yung type is equal to simple. Mas naiintindihan siya. Okay. Although, although medyo mahirap pa rin. Alright. So, ito din, yung kanina, AC is less than 0.001, LB less than 136, FM less than 0.112, then dito siya. And probability na normal siya, 0.71%. And yung pumasok dito sa path na to, 405 observations. Out of the total na, dun sa training data, 405 yung observations na pumasok dito. Tapos dito naman class, dito is pathologic, no? 11 lang yung pumasok na pathologic. Diba sabi natin, isa lang. Node 5 yung pathologic, node 6 yung suspect. Yun yung probability. 0.401, 0.497, 0.102. Pinakamalaki si suspect, no? And 314 observations dito. The rest are all, lahat ano na, no? Ano to? 1. Ito 1 din. 1. 1. 1. 1. 1. And that's to be expected kasi around 80% ng 78% ng observations natin normal. Diba? Okay? So dito sa 1,700 ba? 1,700 na train belonging to train data. 11 dun yung pathologic, 314 yung suspect. The rest, if you add all of this, 405 plus 103 plus 7, kasi lahat yan, ang probabilities yan, yung normal, di ba? Okay, so this is another way to plot it. Any questions so far, class? Okay, nakapasa naman ako sa oras. Any questions, class? Okay, good. Alright, so at least nakaano tayo isang example ng decision tree ngayon, no? Okay. Now, ito, let me share this with you. Pwede natin makontrol yung decision tree natin. Control C. Pwede natin medyo mabago yung yung how the process of splitting the data into N, S, or P. Okay, that may be controlled. Okay, take a look at this. So, nag-create tayo ng panibagong object 3.1a. Ganun din, class. Pero, may nagdagdag na function dito. Yan. So, ano yung nagdagdag na function dito? Controls is equal to C3 control, minimum criterion 0.9, minimum split is 50. Okay. So, ang question nito, what's the meaning of this? Minimum criterion 0.9, minimum split is 50. Okay. So, let's first run this. Run na natin run natin lang. Okay? We're able to follow along, class? Okay, sige. Tingnan natin yan kung ano nangyari dito. Let me just use this plot 318. Itong simple. Ano yung difference ng class? Ano yung difference niya? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, dumami yung di ba? Dumami yung terminal nodes natin. Okay? Dumami yung terminal nodes and you can see now na magkakaiba yung distribution nila. Okay, dito, okay, let me continue natin. Okay, so dito class, sa node 4, si normal, node 5 dito si pa rin, si pathologic, node, so medyo nabago na dito, si node 9 na dito yung yung suspect, okay? Pero ganun pa rin, marami pa rin si normal. Pero class nabago yung nabago na yung natin, yung kasi meron tayong 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 na yung terminal nodes. Tapos nabago, ibig sabihin nabago na yung process ng pag-split niya. And that has something to do with the C3 control. So I would that you, class, check kung ano ba to, ano ibig sabihin ng minimum criterion is equal to 0.9 at saka minimum split is equal to 50. Okay? Alright, so may isang example pa dito, 3.1b. Minimum criteria naman is 0.999, minimum split is 500. So I leave you guys to run that. No? I want now to go here. Okay. So dito tingnan natin na ito. Sige, i-run ko na muna to. Okay, so dito class, apat na lang yung ano, no? Apat na lang yung 3 nodes natin. No? Okay. It became 4 and ang disadvantage nito class, medyo tingnan nyo. In fact, dito class, apat na lang yung nodes natin, terminal nodes. Wala na tayong na predict na pathologic, di ba yung 3? Kasi tingnan nyo to, si node 3, okay, si node 3, ano na to, normal. Si node 4, suspect. Si node 6, normal. Si node 7, normal. So you can see here, there has to be a balance. Kung masyado ng konti yung decision tree, yung konti yung konti na class yung terminal nodes natin, okay, that will not give us a good prediction kasi possible, in this case, nawala yung di ba? Nawala na yung number 3 sa predictions dito. Pag masyado namang class, masyado namang too many, okay, may disadvantage din yung kung masyadong marami yung terminal nodes natin. Okay, so there has to be a balance, no? All right. So here, okay, di ba nag 3.1b na tayo? Okay, gamitin lang natin to, no? Yung 3.1b natin. Okay, so what am I doing here? It's almost time class. If you need to go class, na lang but allow me please just to finish. Kahit hanggang dito lang sa misclassification. Okay. All right. So if you take a look at this, okay. So I'm going to create this object P1T, P1 predict 1, and then I'm going to use the predict function using the 3.1b for my train data. Okay, so if I run this, so meron tayong P1T dito, no? Ito yung P1T natin. Yan. Okay, so anong result ng P1T natin, class? Tingnan niyo. Okay, so P1T is also 1, 2, 3, 1, 2, 3, di ba? So i-compare natin, class, head ni P1T, din natin 20, first 20 observations, at saka yung train. Alright. Compare natin siya, tingnan natin, class, kung ano yung naging resulta. Okay. Dapat yung lang, sorry. Train ng NSP F lang. Okay, take a look at this class. So yung predict natin, ito yun. 1, 1, 1, 1, 1, 2, 2, 1, 1, 1, 1, 2. Okay? Yung actual natin, 2, 1, 1, 3, 3, 3, 2, 2, 1, 1, 2. So kita natin, di ba? So in fact, class, yung natin, yung 3.1b natin, yung apat na lang yung terminal nodes. Walang siya eh. Wala siyang number 3, no? Wala siyang pathologic kasi apat na lang yung apat na lang yung terminal nodes eh. So lumiit na talaga yung yung terminal nodes natin doon. Okay, so you can see here the difference between yung head natin, yung actual value ng train data set natin. Yung unang observations pa lang, ang dami ng mali talaga. Alright, so this one will now compute for the misclassification error. Okay, so as I said, if you need to go, please do so. I'll just discuss this, So anong ginagawa natin dito, class? Wait. Hindi ko pa na-share sa inyo to, Did I share this with you, class, itong controls? Nakuha nyo? Hello?
Sir, yung 3.1b po.
3.1 saan?
Ayan, sir, 3.1b.
Okay, this one. This one?
Yes, sir.
Okay, sige. I-share ko na hanggang dito na sa sa misclassification. Control C. Okay. Pasensya na class ha. If you need to go, please go. Para lang ma-record na natin to kasi sabi ko in the interest of time talaga. Ano pa. Hindi kaya ng lahat. No? Sige, part ko na lang. Ito yung ayoko kay Zoom. Masyadong limited ka. Itong unang dalawa muna. Okay, Control C. Okay. Alright. So, dito na tayo, no? Alright. Yan yung 3.1b kanina. No? Sabi natin hindi maganda. Okay. So, gagamitin natin class si C.1a 12 yan, di ba? Naalala nyo si 3.1a? Yung 3.1, ano lang, 10. Si 3.1a, 12 naman. No? So, let's just use 3.1a as a basis for our model. Not 3.1b kasi apat lang siya. Sabi natin, yung 3.1b, ano na eh. I-validate na natin ngayon klase 3.1a. No? So here, I'm creating this object, tab.1a, and gagawa tayo ng table. Okay? So predicted is equal to yung predict 3.1a. In other words, class, yung model na ginawa natin na .1a, i-predict natin, okay? And then i-compare natin sa actual ng train and SPF. Alright? Okay, so table to, no? Table. If I run this, and then if you print ko si table 0.1a, take a look at this. Okay, ito, plus. Ito na yung this is now what we call the confusion matrix or misclassification matrix or confusion matrix. Bakit? Ito class yung actual, yung 1, 2, 3, ito yung predicted. No? So ito yung record ng performance ni 3.1a. So dito class, predicted natin, predict na 1, so tama, 1 siya, 1, 3, o 4. Ito yung diagonals natin class, ito yung tamang prediction. Kasi predict natin na 2, tapos actually 2 siya, 95. Predict natin na 3 siya, tapos actually 3 siya, 11. So the rest, the off diagonals are wrong predictions. No? Mali ng model natin. Predict natin na 1 siya, pero yung actually number 2 siya, no? 131. Predict natin na 1, pero number 3 siya, 109 na mali. Okay, so yung mga mali natin class, 44, 131, 109, 24. Yung mga tama natin, 1304, 95, 11. Okay, so we can now compute for, ano yung mga correct natin? 1304, 95, 11 divided by the total. No? So, ang code lang yan, sum of the diagonal ng table natin divided by sum ng buong table. Okay, that's just simple arithmetic. All right? So, you can see here that the correct prediction proportion is 82. So, therefore, ang mali, 1 minus lang yun. All right? 17%. So, using and then as an exercise, tingnan nyo yung 3.1 kung okay ba siya. No? Ito, lalo naman yung 3.1b, ano nyo lang klasa, subukan nyo lang i-run, just replace yung mga values dito, 3.1a, 3.1, 3.1b. I leave that to you class. No? Actually, ito, no? Ito yung 3.1b. So let me just run everything here. Itong ginamit dito, 3.1b, and we said that palpak tong model na to. No? Tingnan natin. Alright. So ito, di ba? Wala siyang na-predict na tama dun sa wala siyang tama dito sa number 3. Okay? Wala siyang tama. Kasi nga, di ba, ang prediction niya dito, lahat number, wala nang 2, lahat number 3 na. And ang performance siya 80%, no? As compared to 82%. Siyempre, mas maganda yung 3.1a. Alright? And then lastly, class, okay? Lastly, ito. Now, how will our model compare with the validate dataset? Let me share this with you. Kasi ang ginawa natin dito, minodel natin yung train dataset. Sabi natin, i-test natin ngayon, no? Tingnan natin kung okay siya sa validation dataset natin. Okay, so let me run that. Okay, last na to, class. Okay, so here I'm creating this object. First, P1V, ito yung validate natin, ano? Predict using 3.1a yung validate dataset. Okay, so ito medyo na validate na yung ginagamit natin dito. So if I run this, okay, it will now, itong predict na to, kasi pinaprint ko siya, no? Okay, sorry ang haba ng ano, dapat hindi ko nalang print. No? So ang generate niya, ito yung mga prediction siya. Yung mga 1s, 2s, and 3s. And ito yung equivalent probabilities. Okay? Probability na 1 siya, 0.98. So papasok siya talaga sa 1. Okay, pag mas malaki siya among the 3 probabilities, dun siya papasok sa classification yun. Alright? And then let's now count kung how well our model performed with the validation dataset. Okay, so saan siya? Dito. Alright, we now go here. Ito na, no? Again, table.1a, validate. Nabigay ko na sa inyo to, no? Pareho lang yan na nasa taas kanina. Gagawa lang yan ng confusion matrix. And then, i-compute niya yung ano, yung, okay. Oops, sandali. Saan ako nagkamali? Tab.1av is predicted is equal to P1V. Ako naman siya, may P1V na tayo. Validate is NSP. At nagkamali siya. Table, predicted 1V. Actual validate NSP. Okay, print. So, saan ako nagkamali? Okay. Okay, class, i-decipher na lang natin kung ano, kung, kasi ito, P1V, no? Ito yung P1V, tama naman tayo. So, meron tayong P1V. Okay. Wait, no? Ito kasi ginawa siyang probability. Let me run again P1V, ito. Okay, so tanggalin ko na yung ano dito. Kasi nag-P1V ulit ako no? So naging dalawa yung P1V ko. Yung isa, yung values na 1, yung isa naman yung probability. So let me try this now. Okay, tama na, no? Alright, ang maliit natin dito, class, nag-second na P1V ako. Yung P1V na yan, ang type ng probabilities. So hindi yan yung 1 at saka 2 at saka 3. So when we were comparing that with the validate na NSPF, mali tayo. So dapat I can just put this as siguro underscore P. Underscore P na lang. Probabilities. Okay, so binago ko na lang siya. So tama na to, no? If I run this now, okay, so you will have class, kung rinan nyo to kanina, dapat i-run nyo ulit yung P1V para maging, ano siya, yung 1, 2, or 3 yung values. Okay, so take a look at this. Ang performance siya 80% at saka 20%. Okay, so yung ano natin yung actual 82% at saka yung 80%. Okay, so not really that far. No? Not really that far. All right, so let me stop there. Okay, stop recording.